Good afternoon. Welcome one and all for the another session of AVL.com. The project has been started by GTU. In my last lecture, we have seen about the basics and the fundamentals of the electrical engineering. We have seen the difference between conductor, insulator, resistors, and we have also seen some laws like Ohm's law, Kirchhoff current law, Kirchhoff voltage law, and we have also seen some of the connections, that is series parallel connection, and we have also solved some numericals. Now I will show you some of the slides that will give you the live demonstration of the connections. That is, here the study of voltage and current. Here I am connecting three different resistors. One is having value 100 ohm, another one is 200, and third one is 220 ohm. So what you can see, that if they are in series with the 5 volt battery, so what will happen, that the voltage will be different, right? So this way the actual setup will look like. Now we'll see what is voltage in parallel. Suppose I am connecting three different resistors. One is 100 ohm, another one is 200, and the third one is 332 ohm. So what will happen, if you want to measure the voltage, so how you can measure the voltage? You have to connect the voltmeter in parallel with the resistor. So here I have connected one voltmeter with the R1, another one with the R2, and third one with the R3. So I can see that as these are in parallel, so the voltage is same. Now we'll see the combination of voltage. That is, I am connecting 100 ohm, 200 and 300 ohm resistor. So here you can see that these two resistors, that is R2 and R3, are in parallel. So what you can see, that the voltage is same, and here in R1 the voltage is different. Same way you can do in the current in series. So if I am connecting three different resistors in series, so you can see that the current that is shown by the ammeter. Generally the ammeter is connected in series, right? Now current in parallel, you can see that the three different resistors, R1 is equal to 100 ohm, R2 is equal to 200 ohm, and R3 is equal to 332 ohm. So the current that is shown by this ammeter, that this ammeter is connected in series with the resistor, so it is different, right? Okay, now we have also seen the Kirchhoff law. So based on the Kirchhoff law, one can solve the numericals, right? So here in this lecture we will try to solve how to solve the examples, right? So here you can see that based on the first law, what is the Kirchhoff first law? Kirchhoff first law states that the summation of the current, that is sigma I, is equal to 0, whether it is incoming current or outgoing current. But for writing these circuits, you have to first write down some equations, right? So after finding the equation, if you want to measure that how much is the current across this R1, you can see that here in the R1 the current is 9.92. Same way the current in this R4 is equal to 0.16. Same way the Kirchhoff second law can also be verified, where you can find out the voltage. Mind well, Kirchhoff current law can be used to find out the first law, can be used to find out the unknown current, and the Kirchhoff second law can be used to find out the node voltage. From the Kirchhoff voltage law, we can find out the how much is the voltage that is coming across the junction or across the node, right? So it is same that E source is equal to E1 plus E2 plus E3 is equal to I1 R1 plus I2 R2 plus I3 R3. Okay, now in lecture we will see how to solve these numericals and how to find out the different current values. Okay, so first example we will see based on the Kirchhoff current law, right? These are the things that we have already seen, just I am giving you a quick revision. Okay, the first example is this. Here in this example you need to find out the current that is supplied by each battery in the circuit that is shown in this figure. So here you can see that four batteries are connected. One is 20 volt, another one is 5 volt, third one is 5 volt, and last one is 30 volt. So how you can find out the current from the circuit? So first thing is that you need to write down the different equations. So how to form the equations, that we'll see. So see, for the loop 1 you have to first write the equation. So whenever you are writing the loop equation, you have to consider the things which we have seen in the last lecture. We have seen that we have to consider two sign, that is one sign is regarding the battery EMF and another sign is regarding the sign of IR drop. Okay, so whenever you are tracing any circuit and if the battery comes, then you have to see that whether the magnitude of the battery is increase or it is decrease. If it is increase, that is if there is a rise in voltage, then you have to take a positive sign. If the battery EMF is getting fall, then you have to take battery sign as a negative, right? And same way, when the voltage drop is occur, at that time you have to consider that how you have to select the battery sign. Okay, so for this example, first we will assume some direction, that is in this loop I am assuming that my direction of this loop is clockwise, right? And here it is also clockwise, and here it is also, here it is a anti-clockwise, right? So how I can write the equation? I have to start with this direction, that is here if I am moving from this point to this point, so what is happening? My voltage, that is the battery voltage, is getting increased, that is there is a rise in potential, that is from minus to plus, that is negative to positive. That means the battery sign will be positive. Then here resistor is connected with the showing I1, that is 5I1 plus 3. Now this 3 is the resistor element which is connected with the two loop, that is one is this loop, another one is this loop. So I have to write 3 in bracket I1 minus I2. Then again this battery is coming, so the battery magnitude is, you have to see that it is positive to negative, that means it is fall in magnitude, so you have to take a negative sign. So how to write the equation? Your equation will look like this, that it will be 20 minus 5I1 minus 3I1 minus I2 minus 5. I have taken 20 as a plus because my battery sign is from negative to positive, while here my battery sign is positive to negative, right? So that's why I have wrote 20 minus 5I1 minus 3 in bracket I1 minus I2 minus 5 is equal to 0. Okay, now if I simplify it, so what will happen? 20 minus 5I1 minus 3I1 minus 3I2 minus 5 is equal to 0. So what will happen? 3I1 minus 3I1 minus 5I1, that is 8I1, and I2, that is 3I2 is equal to 20 minus 5, that is 15. So that's why I have wrote this equation, that is 8I1 minus 3I2 is equal to 15. Now I want to write the second equation. So how I can write second equation? See, again I have to see the circuit. See, in the circuit I have to trace that if I am starting from this point, so what is happening? It is 4I2. Now the battery sign here, it is negative to positive, that means it is a rise in potential, that means you have to take plus 5 volt. Then the second element, that is 2 ohm is coming, but the 2 ohm is connected between I2 and I3, so you have to take plus 2 in bracket I2 minus I3, then the battery sign. So same way you have to write the second equation. Okay, so after writing 3 loop equation, loop 1, loop 2 and loop 3, you will be getting 3 equations. So now after solving these 3 equations, you will get to know about the 3 values of the current, that is I1, I2 and I3. See, here in this example my value of the current is negative, So one may be having a question in their mind that whether the current or voltage is in negative. No, it is not in negative. So what I have to assume that the direction which I have assumed in my example is different. So I have to take this sign and the answer will be same, but it will be considered as a positive sign. Okay. Now we'll see second example. See, in this example you have to find out the branch current in the circuit by using the nodal analysis, or it is also called as a Kirchhoff current law or KCL. So you have to apply a Kirchhoff current law, and based on the Kirchhoff current law you have to find out the total current or the branch current, right? That is, this one is called the branch. Okay. So how many branches are there in this circuit? Here it is 1, 2, 3, 4, 5. There are 5 branches. So you have to find 5 different branch current as well as the current that is flowing in the resistor, that is I1, I2, I3, I4 and I5. You have to find out 5 different current. So for doing the KCL analysis you have to first consider how many nodes are there. This one is the node A and this one is the node B. Okay. Now you have to take a reference node. With reference nodes you have to write down the equations based on the Kirchhoff current law. Okay. So how I can write? To do the nodal analysis, the first equation of node A can be written by inception of Kirchhoff current law. What is the statement of Kirchhoff current law? Kirchhoff current law states that the summation of the current will be 0. So how I can find current? Current I can find by V is equal to IR, all we know, right? So I is equal to V by R. So I have to write V, and whatever amount of resistor are there I have to take as a denominator. So I can write for the first node, that is this node, that is VA. See, whenever you are writing the nodal equation you have to go through the reference node, and in between that whichever the resistors are there you have to put as a denominator. So for simplicity I am writing a equation, that is VA in bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is, if I am going from node A to reference node, I will write the R1, then R2 and R3. These are the 3 terms that are coming, right? So that's why I have wrote this equation. Now after putting the same way I have to write the node B equation. So node B equation I have to check that node B whether it is connected with the which node, that is here it is first connected with one reference node and another with the node A, right? So I will write this equation that is based on the Kirchhoff current law. Now I will put the data, that is the value which I know. So the value of R1, R2, R3 and the EMF, that is the battery voltage we know from the example data. So we have put this data and we have formed one equation. Same way we have to put the data in the second equation, that is for the node B, the equation will becomes like this. Or simplicity it will be 2VA minus VB is equal to minus 3, and second equation is equal to VB minus VA divided by 2 is equal to 5. Now I have to solve these 2 equations. So based on the 2 equation solving I will get 2 different value. One is VA and another one is VB. Okay. So from 1 and 2 I get VA and VB. Now I have to put this VA and VB value in the equation. So I will get the value of I1. So I1 is nothing but E1 minus VA divided by R1. Actually I is equal to V by R, but there is a certain voltage drop that is occurring. See, you can see from the figure that R1 is the resistor that is connected with the battery. So what will happen, that in between when the current will reach voltage will reach up to point node A, there will be certain drop will occur. So that drop I have to consider, and based on that I have to find out the value of I1. Same way I have to find out I2, I3, I4 and I5, right? So this way you can solve the Kirchhoff current law and Kirchhoff voltage law example. Now we will see that suppose there is a electrical circuit, that circuit may be a DC circuit. So in the DC circuit, suppose the circuit is very much complicated, even though you cannot solve it with the Kirchhoff current law, Kirchhoff voltage law, even though you are applying series and parallel resistance combination and finding out the equivalent resistance. So at that time what you will do, or in some of the circuit may be a complicated circuit. So for solving the complicated circuit, we have developed one technique, or there is a one technique that is called the star to delta transformation. So first we will derive that which are the equation or how the transformation can be occur, and based on that we will solve some numericals. That numericals are very much important for the exam point of view and for the interest point of view also. Okay, so the star and delta, so circuits are sometimes called the different names according to their shape. So this circuit is the same circuit that you are showing here. It is connected in the star fashion. So the left hand circuit is a T shaped network, and the one at the right is called the Y network. So here you can see that three different resistors are connected, RA, RB and RC. Okay, now similarly for delta, there is a both the following networks are the same. The one on the left hand is called pi network, and the one in the right is called the delta, because the forms resemble those Greek characters. This delta and pi are the Greek characters. So one method is that in your network or in your circuit, the circuit may be connected likewise, or it may be connected this way, or it may be connected as a delta fashion. So how to convert star into delta? See, here you can see that this RB and RC are in parallel, right? Same way what you can see that RA and R2 and R3 are in series. Okay, so a part of a larger circuit that is configured with the three terminal network